Hello, welcome to Z Talk. It's been a quite while since my last session about Terraform. I've been receiving good questions and comments since then. So I want to take this time to thank you all for being part of my learning journey. One of the good ones was asking if I can have a follow-up session about best practices of managing Terraform state files. So in this session, I'd like to walk you through a couple of options. I guess there's no need to emphasize how important the Terraform state files are. It's for resource tracking. It's a way that Terraform uses to identify what resources have been deployed on your infrastructure. So whenever you deploy resources with Terraform, all the information, metadata about the resources are stored or recorded in a JSON format Terraform state file, which named as terraform.tfstate. Remember, this state file is like a private API, which means you should never ever edit this file by hand or write code that reads them directly. I want to emphasize here because I saw questions like if someone else manually updated some resources in your org, which broke Terraform, how do you manipulate the state file to recover it? I think a better fix for this kind of scenario is to consider locking down your environment in the first place, especially production, to prevent any manual intervention from happening. Or you can try Terraform refresh command to reconcile if things were already broken and you are trying to fix it as a workaround. The point is, do not touch this state file manually, right? Continue on our topic. If you're using Terraform for a personal project, it might make sense to just store your state file on your local, and it works just fine. But if we're talking about enterprise level best practices, using Terraform as a team on real products, you're going to run into at least two problems. For example, you need to store the state files in a shared location, firstly, to be able to access the same Terraform state file by each of your teammates, right? And as soon as data is shared, you are going to run into another problem, which is locking problem. Without locking, if two teammates are running Terraform at the same time, you can run into race conditions, which is highly likely going to lead to data loss or state file corruption. So let's tackle these problems down one by one. As we know, the most common technique for allowing multiple people to access a common set of files is to put them in version control, like Git, right? You should definitely store your Terraform code in version control. However, it's a bad idea storing Terraform state in version control because of highly likely different kind of manual errors. Plus, most version control systems do not provide any form of locking mechanism. And what's more, from security point of view, data in Terraform state file is stored in completely plain text. This is for sure a security vulnerability because certain Terraform resources do need to store sensitive data, right? So instead of using version control, the best way to manage shared storage for a state file is to use Terraform's built-in support for remote backends. Remote backends allow you to store the state file in a remote shared store with locking versioning supported. I will walk you through a couple of options shortly. The first one you can consider is to use PostgresDB. So let's quickly switch to my console and start a demo to set remote store as PostgresDB. All right. I had Postgres installed on my local with Homebrew. It's up and running. Next, I'm gonna do some preparation, like create a new database instance, username, password, etc. By the way, don't worry if I were too fast and you missed a couple of steps. I promise you I'm gonna write down the configuration step by step and share with you in the description of this video. And also I'm gonna share with you the GitHub repo such that you can reproduce and play with on your end. All right. So let's get access to these PostgresDB with CLI by psql Postgres. This is the default DB instance if you install with Homebrew, right? So now let's create a new instance for storing our Terraform state files, right? So create database, let's call it Terraform_state. All right, the new DB instance was created successfully. To double check, we can do \l as the list to list out all DB instances available on this DB, and we can see the new instance was created successfully right here. Next, we're gonna switch to this new instance and create a dedicated user and assign privileges to that user to access these DB instance. All right, so let's do switch by \c as connect Terraform_state. Now we're switching to the new instance and we're gonna create a new user called let's call it Terraform with password. Let's give a simple password. How about 123? All right. Create new role. So we can do user to check the new user created right here, right? Now let's assign some privileges to this new role by grant all on database Terraform_state to Terraform, which is the user name. All right, granted. Now we're pretty much done with the configuration on the PostgresDB side. We are ready to move to the Terraform code, Terraform configuration to add our remote backend. To avoid exposing sensitive data like username, password for accessing DB in version control, I just use partial configuration by adding this block of declaration here to declare that I just gonna use PostgresDB as the remote backend, and I copy this simple configuration in two different folders, test1 and test2. The goal is to simulate a race condition where two users are gonna run Terraform against the same state file to verify if PostgresDB has that state locking mechanism to prevent racing condition from happening. All right. So let's move to the terminal. Here I had two sessions open. One points to the test1 folder, the other points to test2. And I'm gonna run Terraform init test1 folder because I was using partial configuration, right, in the code. So here in the command line, I have to provide detailed information how to hook up with that PostgresDB that was created just now. So here the syntax is using these backend config flag, and Terraform 123 was the username and password that was just created, and the PostgresDB was hosted on my local, and Terraform_stage was the new DB instance, right? Because it's hosted on local, so the SSL mode was disabled right here. So let's kick it off. So once, okay, it's already past the initialization. So what we can verify here on the database side, we can see if there's any table being created automatically. So to verify that, let me open a DB client. Here I'm using dbgate to verify. Let's refresh. And here we go. There was a new table created within Terraform_state instance, and the table name is Terraform_remote_state.states. All right, and on the right side you can see the schema of these new table. All right, looks good. So back to my terminal. Let's continue by issuing Terraform plan to verify if there's any syntax error, possibly. All right, so it passed the syntax checking. So let's run Terraform apply. All right. So here, before we fill in yes to kick it off, we want to hold on here because to simulate that race condition, we want the first user keep occupying the state file. So let's move to the second user, test2. Do the same thing. Terraform init, hit enter. Terraform plan here. So what is supposed to happen once I issue this command? Because the first user is still using these state files, so a state lock or lock supposed to be enabled. So I should get some error message saying already locked for workspace creation, right? Because the second user has to wait until the first user's job is done and the log is released, right? So that's exactly what we're looking for. Let's hit yes here to finish the job and release the log state so that we can verify if we're still seeing the same error on the second user. So let's give a little bit time. It should be pretty fast. On the same time, let me switch to my AWS account, and here we go. The instance is up and running, right? For test user 1. All right, good. The apply complete. Now the log's supposed to be released. If we do this same command, Terraform plan for the second user, and there should be no error anymore. All right, so no error, passed. All right, last but not least, let's take a look the table one more time. We're supposed to see some updates. So let me refresh and do a query. So we can do select star from Terraform remote states table, and here we go. So we got some data. So this was the last date file that recorded these resource that EC2 instance being created. All right, looks good. Let's move to the next option. So let me switch to my PPT. All right, S3. So let's move to the next options. We're gonna test out two cloud solutions, AWS S3 and Azure Blob storage. Along with the benefits of cloud solutions, S3 and Azure Blob do come with encryption, locking, and versioning capabilities. So let me start with S3. As it requires a few more steps, because comparing with Azure Blob, which supports both state locking and consistency checking natively, the state locking and consistency checking functionality is actually achieved by using DynamoDB on AWS side. So, which means it requires us to create a DynamoDB table along with S3 buckets. So let's jump to the second demo to walk you through in detail. Speaking of configuration of resources for remote backend on the cloud side, I think you can do this manually, considering is kind of one-time thing. On AWS, all you need to do is to create a S3 bucket and then a DynamoDB table. I guess the only thing you may want to pay attention is while you're configuring your DB table, you must use a specific string as the primary key of your table. Let me find that key. Here we go. Here, like I highlight line 71, lock ID. Remember this pattern. It has to be lock uppercase I, uppercase D as the primary key of your table to have the state locking mechanism working as expected for Terraform. Other than that, it should be pretty straightforward. On Azure side, you just need to create a resource group and then create a storage account within that resource group. And lastly, create a blob container for storing the Terraform state file within that storage account. And that's pretty much all. I don't want to spend too much time to walk you through in detail if you go this way manually, because I'm sure you can figure it out on your own. It's pretty straightforward. I'd like to spend a little bit of time on the second option. Actually, that's the option I would recommend. I would recommend to consider automating even this simple process by Terraform itself. You know, we're talking about enterprise level management, so we better have this kind of mentality of automation. We try automating process as much as possible to avoid any human intervention from happening, right? That's where error or stupid mistake comes from, most likely, right? So if you go with me with these options, I guess you will quickly run into a tricky situation, or I call it chicken and egg situation. but there's definitely a fix for that. Let me walk you through. So let me switch quickly back to my PPT to talk about these chicken egg limitation. So that's a important limitation I would like you to be aware of for using these remote backend solution, because nothing is perfect, right? So the fix for these situation is let's talk about the creation part of the resources. There are two-step process to create the storage process for both Azure and AWS. So step one, you write your Terraform code to create the S3 bucket and DynamoDB table and deploy that code with a local backend. But our goal is to store or save file on a remote backend so everybody can get access, right? It's a teamwork, right? So that comes to the second step. We would go back to our Terraform code, add a remote backend configuration to it to use the newly created S3 bucket and DynamoDB table as step one, and run Terraform init again to copy your local state to S3. That's the way how we fix this situation. So then let's speak about deletion. So it's the same concept or same two-step process in reverse way. So firstly, we go to the Terraform code, remove the backend configuration, and rerun the Terraform init to copy the Terraform state file back down to our local disk. And then we run Terraform destroy to delete the S3 bucket and DynamoDB table. That's pretty much the fix for this tricky situation or limitation for this remote backend solution. I know it's kind of a tedious process, but good news is that you can share a single S3 and DynamoDB table across all of your Terraform code. So it's an one-time action to take, right? So not that bad. Back to my Visual Studio Code. To save you some time, I've created the Terraform configuration for creating the storage resources for remote backend for both Azure and AWS. I'm gonna share these code base in the description of this video. Feel free to download there and use it as a starting point when you're creating your own stuff. I think it could help you get up to speed, right? Now, I want to spend a little bit of time to explain some statements in each of the resources so you're clear why I did it this way. Let's start with AWS. So under the AWS folder, there's a subfolder called Terraform States. That's where all the Terraform configuration for creating S3 bucket and DynamoDB table reside. And let's go over this configuration. Starting from the first resource for creating S3 buckets, the things I want to bring up is at line number 3. You see I explicitly set a optional argument for destroy as true. The reason I did that is to avoid a possible failure when we need to destroy these resource with Terraform destroy commands. Just let me see if I can show you that snapshot. Here we go. Just in case you did not explicitly set these argument as true, when you run Terraform destroy, highly likely you're going to run into the same error that I had here. It says the bucket you try to delete is not empty. You must delete all versions in the bucket. If you create a bucket, again, without these arguments as set as true, even if you add it later, you still can't force destroy it because the resource in the state file still has the original settings, like default setting, which is false. So a workaround is to once you see this error, you can add these specific line of code and rerun Terraform apply, and then Terraform deletes. That way, you won't see that error again. But just to save you a couple of steps, you can just add these statements in the first place. All right, move to the next resource, versioning. So actually, it's a recommended practice for enabling versioning. This way, it allows you to see older version of the file and revert to those older versions at any time, which can be a useful fallback mechanism if something goes wrong, right? The third resources was here. Let me see, from line 24 to 32, I had a resource to turn server-side encryption on by default for all data written to these buckets, because this ensures that your state files and any secrets they might contain are always encrypted on disk when stored in S3. Other than that, from line 23 to the end of the configuration, I basically, from line 23 to 66, I added additional access control to the bucket, basically to make sure the communication to this bucket is secured. All right. Lastly, from line 68 to 77, the resource is for creating the DynamoDB table. As mentioned, one thing you need to pay attention is the primary key. You must use these specific string called log ID as the primary key to have the state logging mechanism working as expected with Terraform. That's pretty much it. So let's switch to my console and run Terraform, and let me walk you through that fix for that tricky scenario or chicken and egg situation. So let me switch to my terminal. Just follow the two-step process that I talk about to fix that chicken egg situation. Let's run Terraform init first. All right, the initialization is done successfully. And next step, let's run Terraform plan. All right, everything works as expected. As you can see, there's gonna be 6 resources added to the plan. And let's run Terraform apply. And yes. All right, we finished the first step. As you can see, there were 6 resources created, and the Terraform state file created where's that? Terraform state file, TF state file was created on our local. And before we switch to the second step, let me switch to the AWS console and verify the resources. Here we go. Let's go to S3 bucket. And this is the bucket that was created by Terraform, and there was empty as expected, right? So now the second step, oh, one more thing to verify, DynamoDB table. So let's go to DynamoDB service, and there should be a table created by creating tables. And refresh. Oh, sorry, I was wrong at the wrong geo region. It should be US West 2. Alright, as you can see, the table Terraform logs was created successfully with Terraform. So we're good to go to the next step. Copy these Terraform state file from local to the remote backend, which is S3 buckets. So to do that, the things we need to add is to inside of the main Terraform file, we need to update the backend configuration using the newly created resources. So let me uncomment this configuration. We're using S3 as the backend, the name of the bucket, the key, the region, and the name of the DynamoDB table. All right, so let's save that and rerun Terraform init. Clear it out and Terraform init. And now you see it says, do you want to copy existing state to the new backend? So let's type in yes. All right, it says successfully configure the backend S3, and the Terraform will automatically use this backend unless backend configuration changes. And now if we switch to the console and check the S3 bucket, the state file should be uploaded to this remote backend if everything works as expected. So click the bucket, and here we go. This is the Terraform state file. All right, it worked as expected. One more comment before I destroy this resource. With this backend enabled, Terraform will automatically pull the latest state from these S3 buckets before running a command and automatically push the latest state to the S3 buckets after running a command, right? One more thing to confirm is the locking mechanism is enabled. So like the lock highlight here, after I issue Terraform apply command, as you can see, is first refreshing the state in the DynamoDB Terraform logs table, which guarantees that the racing condition that we simulate in the first lap will not happen, because we have this capability enabled with combination of DynamoDB and S3. All right, so let's destroy the resource. Remember that two-step process in the reverse way. Let me switch to my Visual Studio Code and go to that main.tf what we need to do, we need to uncomment this Terraform backend, because what we want to do, we want to download or copy the state file from remote backend to local before we run Terraform destroy, right? So here, let's run Terraform init again. Right, looks good. Terraform init. Yeah, it says backend configuration changed. So we want to do a state migration. So we need to use the Terraform init migrate state flag. Pay attention on the left side. As you can see, the Terraform state file was downloaded from the remote backend. Let's hit yes. So it says, and successfully unset the backend S3. Terraform will now operate locally. Now we get to run that Terraform destroy to destroy these storage resource that we just created. Here we go. And just type yes. All right, so everything is destroyed successfully. So let's do a validation by going to my AWS account and do a refresh. So the table, the DynamoDB table was deleted, and let's go to S3. The bucket, S3 bucket was deleted as well. Cool. Now let's move to Azure. So it's pretty much the same thing. So I will walk you through pretty quick. Here. So this is the file for configuration file for Azure. Speaking of configuration for Azure, it's even simpler because we know the capability of state locking and versioning come out of box along with Azure Blob. So all I need to do is to create a resource group, a storage account, and a storage container to hold my Terraform state file. That'll be all. I guess the only tricky part is the first resource that I used for creating a random string that you may already aware of. The reason I use this resource and attach a random string right after the string that I define a name of my storage account that I'm going to create was I ran into a weird issue while I was testing. So the Terraform actually failed to create this resource with this name pattern, complaining that the storage account already exists. I'm not sure why, because I checked on the Azure console. I didn't see where does he live, but it just complains already exists. So I guess Azure preserves certain pattern of the string as the name of the storage account, but I'm not sure. So if anyone who watching this video and know why Azure does that, please explain and leave a comment. I would like to know what's going on here. But basically, it's fixed. So next, let's test it out. We're gonna run into the same chicken and egg situation. So we're gonna use that two-step process to fix it. So let's do that. Let me switch to my terminal, and I'm already on the Azure folder. So let me run Terraform init. Terraform apply. Yes. We're waiting. The resource is being created. Let me switch to my browser and access to my Azure account to verify. Here we go. Let me refresh. It's still creating. All right, 4 resources were added. So let's see by refreshing. All right, the resource group was created, and then let's move to storage accounts. Storage accounts. All right, as you can see, a storage account was created, and you can see this weird name, Terraform state SA, along with a random string here. All right, so this is storage account, and there should be a container called Terraform state storage container, right? So all good. Now let's move back to my terminal and update the backend. So here, uncomment this section and fill in the resource information that was newly created. So the resource group name is Terraform state RG, and storage account name should be that one with that weird string. So add this guy, right? So I'll just copy, paste right here, and container name is storage container, and the key is Terraform tf state. All right, looks good. So let's run Terraform init again to change the remote backend. All right, so I want to copy existing state to the new backend. Yes. All right. So now let's verify by going to my browser again. Click that the tf states file was uploaded to these remote storage, right? And like I mentioned, the state locking come as default, so we can see here it shows locking status. Right now it's unlocked. So let's test it out. Let's run something here by Terraform plan and refresh. See here, the status changed to locked because these state files being used. There's a process going on, right? So yeah, that's pretty much it. A quick takeaway. So we went through 3 options for configuring a remote backend. One is using PostgresDB, like running on my local, and we simulate a racing condition to verify with these remote backend solutions, we can avoid this risk condition from breaking or messed up or Terraform state file. And then we went through 2 cloud solutions. One is using Azure Blob, and another is using AWS S3 combined with DynamoDB table. So hopes it helps, and thanks for watching, and leave comments if you have any questions, and I'll see you next time.
Alright, thank you for watching my video. If you think this video is helpful, you're more than welcome to leave any comments. Remember, thumb up, subscribe my video, and also hit the notification bell. See you next time.